Okay, so now we have to be able to understand these forms of this equations, of these functions, these quadratics, so that we can interpret, it says here, determine the characteristics indicated. So we got to find the characteristics. So this one asks, does it open up or down? And I can look and see this is in factored form. This is the letter A. And what do I see? -3. That tells me that the parabola is going to open down because it's negative. Remember, negative makes that frowny face. And then here it says the X-Intercepts. Well, because this is in factored form, it's really easy for me to figure out. I just think, what would turn this into 0? And I'd have -2. And over here I'd have +4. 4 minus 4 is 0. -2 plus 2 is 0. So my X-Intercepts would be at -2 and +4. So that's how I can easily do it in factored form. Here I have vertex form. Now in vertex form, to find out whether or not the parabola opens, I just have to look here at A. Okay, 5. It says 5, that's a positive value there, 5, right? So that means the parabola is opening up. It's opening up, right? And then the vertex is going to be at, this vertex form is AX, let's see this, X minus H squared plus K. X minus H squared plus K. So the vertex is H and K. Okay? And I gotta get rid of that, I'm sorry. Okay, so this one's opening up and the vertex will be H and K. And H and K is X and Y. So let me pause that just for a second. I see this guy's texting me and it keeps showing up on the screen. Okay, sorry about that. So H and K represent the X and the Y value. So X minus 3, so this would be a vertex at 3, comma, plus 4. So K would be 4, so that would be 3, comma, 4 is where it would be. Notice that in the model, this has to be X minus H, minus the vertex value. So this right here, this H right here, it's going to always be the opposite sign of whatever this says. If it says -3, then it's +3. If it says +3, remember it's -3. This value is supposed to be plus K, so this will just, if it's positive, it stays positive for Y. But X and Y, okay? All right, so that gives us our vertex there. Now it says, write a function in vertex form and sketch a graph that has these characteristics. So it's quadratic. We know it's going to have a square. It's in vertex form. It's continuous. That means it's a line that has no breaks in it, not like a discrete one with dots or whatever. And then the parabola opens upward. Okay, so opens upward, so that means it's going to be like a smile. It's opening upward. Okay, that means it's going to be positive for A, right? And the function is translated 3 units down and 3 units to the right of f of x is equal to x squared. So here we go. We have to first of all, let's see, let me get my pen out here. Okay, so we have f of x is equal to, so if I want to go 3 units to the right, that means I have to subtract from x. So we go x minus 3, close that and square it, right? And then if I want to go 3 units down, I've got to subtract 3. And then do I need to put a number up here? No, because it's not being vertically dilated in any kind of way. It's not being vertically dilated. So I just need to make sure that's a positive number here. Okay, so as long as that's a positive number, I'm fine. Okay, it opens upwards, so I know it's a positive number. So that's it. That is the graph there. But now I need to actually draw. They told us to sketch the graph. So let me scroll down a little bit more and I can sketch this graph. So if it is 3 units down, so that'd be down 1, 2, 3. There's 3 right here. And 3 units to the right, 1, 2, 3. Realize I'm using the scale here. This is 3. This would be 2.5. So don't count. It's not 1, 2, 3. That's only 1.5. So I got to go 1, 2, 3, and units down. 1, 2, 3. So that would be my vertex there, and it's opening upwards. So let's draw that. Here we go. From 3, 3, opening upwards, and is going to look something like this. Okay, something like that. Okay. All right, let's keep moving here. And sorry, here we go. Skip the post test. Going to take a look at problems that are different that we can use that are in the, because the post test right there, that's going to be identical. But we're going to take a look at the problems that are different that we can use in this mid-chapter and final chapter test. Okay, so each morning, we worked through this in class a little bit, right? So I'm going to skip through that. I think we got through that in that case. So now we need to calculate the x-intercepts of each function. So I'll start right here at 2a and then 2b. So to get the x-intercepts, what I need to do is factor this out, and I end up with a -7. I'm going to put this in factored form, so I'm going to put -7 on the outside, and then what's on the inside. If I divide -7x by -7, I just get x, right? And I divide 14 by -7, and I get -2. So that's all that's left inside. So there's only going to be one 0, right? There's only going to be one thing that turns this function into 0, and that is when x is equal to +2. 2 times, or 2 minus 2 would make this 0, and 0 times that would be 0. So there's only one place it would be when x is equal to +2. So that would be my x-intercept there. Here I'm going to factor out I'm going to factor out 3x, so I'm going to put 3 on the outside. I'm going to put the x alone by itself, and then what would be left? If I divide this by 3, that's gone. Divide it by x, the only thing left is x, right, in that term. And I look at the second term. This is a binomial, remember, so it has 2 terms, right? The second term is if I divide -6 by 3, I'm going to have -2, right? And then if I divided that x by x, right, because I take the x out here, so there's no more x left. So this is it in factored form, 3 times x minus 2. So what would turn this into 0? Those are my x-intercepts. So obviously if this was 0, if that x was 0, then we would have a function whose multiply all that out and you get 0. And then here we have x minus 2, so I have a second 0. If this was +2, 2 minus 2 is 0. So those would be my x-intercepts, my 2 x-intercepts for that function. Okay, here we go. Okay, we have done this already, first and second differences, in the previous video, so I'm not going to do it again. Okay, now they want to know what type of graph this is, linear or quadratic. This is pretty simple. Okay, so this one is obviously a quadratic because we have a parabola, right? So type of graph is going to be quadratic. Then it says identify, and identify the x-intercepts. So the x-intercepts, here's one at -2 and there's one at +2. So my x-intercepts are -2 and +2. This type of graph goes in a straight line constantly, straight line. So this would be a linear graph, line linear, right? And the x-intercepts, there is only one, and it is at -1. Okay? Here we go. This is a vertical motion, right? Vertical motion function. -16t squared plus 140t describes the height of a model rocket. Graph the function and label the axes. So what I'm going to do is I'm going to, and then it wants to evaluate the height of the model rocket at 5 seconds. So if you use your calculator and you put that in, here's what we're going to do. I'm going to start out a new document, not save any changes to any old documents. Here we go. I go to add a graph. And I'm going to put in -16x squared, okay, plus 140x. And I'm using x instead of t because in our graphing calculator that's kind of what we have to do. So I have an intercept here at 0 and another intercept here just before 9, right about there. I can check. I'm going to change my window settings here. So I'll go menu, 4 for window zoom, and 1 for my window settings. And I'm just going to use these settings here. So I'll go from -4, let's say, out to 12 on my x-axis. So -4 and tab down to 12. And my y-axis went down here from -100 up to, let's see, 350. So I'll go -100 to 350, enter, and I can see now I've got something that goes through 0 and comes down over here, and it looks like it peaks somewhere around 300. Okay, so you can sketch that out if you want, but we need to find some of these values here. So I go Menu, and let's analyze the graph first for the zeros. So just checking the lower side and the upper side. I see I have a 0 at the origin, and then Menu, Analyze Graph for a 0 again. The lower bound just to the left of that number 8 point something, and then go past it just to the right, and I get to 8.75. So I have 8.75 is my other 0 right here, and the other one over here at 0. And now I'm going to Menu, Analyze Graph for the maximum, and I'm going to go to the left of the vertex for the lower bound, and then to click again on the right, and I get 4 point, is that right? I can't see that so well. I have to move this text so I can see a little better because it's overlapping on my calculator. Yeah, 4.38, and then 306. Okay, so now they want me to know what is the height of the model rocket at 5 seconds. Okay, so remember that t, what we used for x was t, and t represents time in this model, right? And the output over here is the height. So the t, they want to know what is the value, what is the height when t equals 5. So you can do that by graph tracing, or what I'm going to do is I'm going to go ahead and do my table, split screen table, and I'm going to go down to where 5, and I see when x equals 5, the value or the height is at 300. Okay, after approximately how many seconds is the model rocket at a height of 200? Okay, so for that I am going to trace. So let me remove the split screen table, remove the table, and then I'm going to do a Menu, 5 for a trace, 1 for a graph trace, and I'm going to go to the left first. I'm looking for when does it get to 200, and it looks like at 1.8, when x is 1.8, so at 1.8 seconds, it is at 200 feet. And then it comes down, it hits 200 feet on its way down again, remember? So going down right here, let's see when it'll stop it, if it'll stop. No, didn't stop it at exactly 200 feet, unfortunately. So I can go Menu, and I can do a 5 trace, and then I can do 3 for a trace step. And it says automatic, but I'm going to make this smaller. I'm going to go 0.02 and hit enter for my trace step. And that way I can really scroll. Oh, that's not even good enough. Let's go Menu, Menu, trace step. Let's make that 0.01 and hit enter. And then if I trace, then I can see that, yep, it hits 6.95, or it hits 200 feet at 6.95 seconds. So it reaches this height at 1.8 and 6.95 seconds using my graph trace, or using my, I could also write a function. That's another way to do it. In fact, that might be the easier way. Let's try that real quick. If I go Menu, Graph Entry Edit, and 1 for function, and I just put in 200 for a second function. And now I want to know where do those two functions intercept. So I go Menu, and I want to analyze my graphs for intersections. I go to the left, and then go to the right of my intersections, and I can see there's 1. Then Menu, analyze my graph for another intersection, 1 on the left and 1 on the right. And where those two intersections occur is exactly where the function's value is at 200, right? Because I just mapped it. So that's another way. We've done that in class, getting ready for this test, and it's just another reminder for you right now, really, is all that is. Okay? All right. So let's see. Use the graph to identify the properties listed for each function. Okay, so the domain. All right, I'm not going to type this because it took so long before, so I'm just going to say it, and you're going to have to listen and follow along. If you need to rewind, you can. But domain. So I can put in any value for x into this. There's nothing that prevents me from putting any number in for x. So my domain is from open parentheses negative, infinity, comma, infinity, positive infinity, and then close parentheses. That'd be my domain. My range, it looks like it maxes out at 8. So my range is anywhere, since it's opening down, open parentheses, negative infinity, comma, 8, and then close with a square bracket because we're going to include 8. Looks like it does reach 8. And then next we have the zeros. I'm just looking at the graph. Zeros at -3 and zeros at 1. Okay, we're eyeballing this. If you want to, you can put it in your calculator and actually analyze and get the exact answers. Or you can do the math and do the exact answers. But I think we're going to eyeball it. We're going to be okay. The interval of increase. So we'd open up parentheses. It's increasing in this direction as we move to the right, increasing until we get to -1. So I'd have open parentheses, negative infinity, comma, -1, close parentheses. My interval of decrease starts right after -1 and goes to infinity. So open parentheses, -1, comma, infinity, close parentheses. And that's what I'd have there for my interval of decrease. Here we go, another one. The domain. Domain is, again, any value of x. I can put any value in for x. So open parentheses, negative infinity, comma, positive infinity, close parentheses. My range starts at 4. So I'd start with a square bracket at 4 because we're going to include 4. Output does appear to include 4. So we got 4 with a square bracket, comma, positive infinity with a parentheses. So starts at 4 and goes up to infinity. My zeros, I have zeros at -3 and +1. So -3, +1. My interval of increase, well, the increase begins right here at -1. So it'd be open parentheses at -1, comma, positive infinity, close parentheses. And my interval of decrease would be open parentheses at negative infinity, and it's decreasing all the way until I get to -1, so comma, -1, close parentheses. Okay, analyze the function 2x squared minus 4x plus 1. They want us to graph it, so I will do that on my calculator here at my desk. Actually, I'll do it on GeoGebra. So here we go. Let me get back to GeoGebra. And I'm going to put that function back in. 2x squared minus 4x plus 1. So my function should be at 2x squared equals 2x squared minus 4x plus 1. Is that right? 2x squared minus 4x plus 1. Yeah. So graph the function. So here I have the zeros already figured out. Well, these are approximate zeros, right? But there's the graph. Looks like it says extremum. That would be my minimum right here. My minimum is right here at 1, -1, and my zeros at 0.290 or 0.29 positive, and then over here at 1.71. Those are rounded, I'm quite certain. Okay, I don't know if they're going to ask me that. There we have it graphed, so it comes down here and it goes back up. And again, it's at 1, -1, so it has a vertex right there. Okay, and it'll go up and up. Okay, determine the absolute maximum or minimum. The minimum of the function is right here, C 1, -1. So I'd put minimum at 1, -1. Okay, complete each table. I'm not going to complete each table because I don't have the time. I don't want to make you take the time to go through that. We've done these already. Use your tables. Put these in as functions, go to the table view, see them, subtract up for first differences and second differences. Okay, here we go. We need to identify these properties here again. So our domain is all values of x, so comma, negative infinity, or open parentheses, negative infinity, comma, positive infinity, close parentheses. Our range, this is 12, 14, 16, so that has to be 18, right? If I count, these are counting by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18. So my range is everything negative or down less than 18. So I would go open parentheses, negative infinity, comma, positive 18, and then a square bracket to include positive 18. Okay, my zeros here, I see one at 1 and I see one at -5. My interval increase is from negative infinity up to negative 2. Once I get to negative 2, it stops. So open parentheses at negative 2. Interval decrease, open parentheses, negative 2, and it goes down for infinity. Okay. Use the given information to write a quadratic function in factored form. Okay, this is good. Okay. We're going to do these real quick. Remember how to do them. So if it opens downward, I have to have a negative a, and the x-intercepts are at 5 and negative 2. So I'm going to make the function look like negative 2, I'll just say. And I'm going to say that it has intercepts at 5 and negative 2, so it's got to be x minus 5, right? I'd make that a 0, and then we would have x plus 2, right? Okay, that's factored form with an a that is negative, so it opens downwards, and with zeros at 5 and negative 2. Okay, it opens upward, so a's got to be positive. The x-intercepts are at the origin and negative 3. So all I need is an x here. And in positive, I can just leave a, any number. I don't know, I'll make it a number. Here we go, 3. I could have just left it 1 or nothing. I don't want to put 0. Can't be 0. But it has to be a positive number. And then over here, I want another 0 at negative 3, so I would go x plus 3, because that will turn that into 0. I would make the negative 3 as 0 here, right? This says write each equation in factored form and determine the x-intercept. So I'm going to factor out the negative 6. If I put negative 6 outside here, then I end up with x squared minus x plus, minus 2, minus 2. Okay, you can use your factored tools in your calculator. You can use the area model, but we could factor that down some more. I'm going to get negative 6, and I'd go x minus 2, and then I'd have x plus 1. I can do these in my head at this point, and I'm not going to go over why to spend the time, your time on that, but I can see now that my zeros are going to be, or my x-intercepts are going to be at 2 and at negative 1, right? Here I factor out the 3, so I get 3 out in front. Then I end up with x squared plus 7x, right? And then plus 12. So I got to think about two factors for 12 that add up to 7, and what I get to is x plus 3 and x plus 4. So there's my factors with a 3 out in front. So I get, and my zeros would have to be at negative 3 here and negative 4 there. Okay, those will be my zeros there. Okay. Now it says define the axis, or determine the axis symmetry for each parabola. So the x-intercepts are at 4 and 12. So I know it's right in between those. So I can add those numbers together. 4 and 12 is 16. Divide it in half and I get 8. So this axis of symmetry will be when x is equal to 8. Now it says two symmetrical points on the parabola are negative 3, 5, 7, 5. So negative 3 plus 7 is 4. Divide that in half and I get 2. So 2 would be my axis of symmetry. It's also 5 away from this, from 7, and 5 away from negative 3. But the trick is you can just add negative 3 and 7 together and get positive 4, and divide it in half, you get 2. Okay? So x equals 2. So that's how you find those axes of symmetries. Determine the vertex of a parabola presented by the equation f of x equals x squared minus 2x minus 8. Two symmetrical points on the parabola are 2, negative 8 and 0, negative 8. Okay, so the vertex is going to be on the axis of symmetry. The axis of symmetry is between the 2 and the 0, which is at 1. So I'd put 1 in here. 1 squared is 1 minus 2 times 1. So 1 minus 2 is negative 1 minus 8. So that would be negative 9, right? So 1 minus 2 is negative 1 minus 8 is negative 9. So my answer here is going to be at 1, comma, the value is negative 9. So my my vertex would be 1, -9. Of course, you can just plot this in your calculator and you can find the vertex, but that's how we do it. Determine another point on the parabola has an axis of symmetry of x equals 4 if one point on the parabola is 0, 2. So I know that the other point is going to have the same value here, right, for y. So we'll just say y equals 2. Right, but what's the x value? It has to be 4 units away. See, this 0 is 4 units away from 4. It's got to be 4 units away in the other direction. So it'd be at 8. So I'd have 0, 2, and 8, 2. Okay, and then the axis of symmetry would be at x equals 4. For each function, determine the characteristics indicated. Parabola opens. This is negative, so it opens down. The y-intercept is right here. Right? C is the y-intercept in standard form, so it would be at 12. So the parabola opens down, y-intercept is 12. Parabola opens, here I have an a value, you can't see it, so it must be positive 1, so it opens up. And the x-intercepts are at -2, positive 7. Here I have the parabola opens, I've got -6 for C, so that opens down. The vertex is going to be at positive 3, -5. Using vertex form, remember, x minus h plus k. So minus h can be 3, but k has to be -5, right? So the vertex is at 3, -5. Using the information given, use the information given to write a possible equation for the quadratic function. So the x-intercepts are -3, 0, and 7, 0. And the parabola opens down. So we'd add those numbers together, -3 and 7. That would give me a axis of symmetry at, what, 2? Right? -3 plus 7 is 4, and then divide that in half is 2. So the axis of symmetry is at 2. But actually, I don't need that. Really, all I needed, I can write it. It doesn't say what form it has to be put in there. I can write it in vertex form. So, or I'm sorry, factored form. So I would have x plus 3. So I'd have, let me write this out. Because I want it to be negative, right? So I'd have -1, let's just say for now. And then I need a 0 at -3. So at x plus 3. Okay, that would give me this 0 here. The -1 makes it open down. And then over here I need x minus 7. So that 7 would be my other 0. Okay, so now I have those zeros in that. Okay, vertex is 2, 8, and the parabola opens up. So the parabola opens up, then I need a positive number for a. And then I have x minus 2, close the parentheses and square that, plus 8. This is just vertex form. All right, why? From x squared, what did we do? Well, we shifted up 8, so y is up at 8. And the vertex is up at 8 now. And this said, go to the right 2, right? So there we have positive 2. So this is vertex form. Remember doing that in our transformations. Okay, write an equation, sketch a graph of a function translated 9 units down, 4 units to the left, then vertically dilated with a dilation factor of 1/2. Okay, here we go. We got to do these fast, man. All right, so translated 9 units down, so we go down 9 units. So that means at the very end, I would normally have -9 there, right? And 4 units to the left, so I'd have to have inside my parentheses here, x plus 4 to translate to the left. And then there's a dilation factor of 1/2. But what does that tell me? Then this would also have to have been multiplied by 1/2, right? I mean, this would have to be at the end. It's going to have to end up at 1/2. So originally this would have to have been at 18, right? Anyway, I write it like that: 1/2 x plus 4 squared minus 9. Okay, let's put that in to our calculator and GeoGebra and just make sure that's what we're actually getting. Sorry, 1/2 x plus 4 squared minus 9. That's what we can put it like that. It would have already, this parentheses shouldn't be there because we would have actually moved it to 18, and then, oh, wait a minute, whoa. It was translated down 9 units and then 4 units to the left, and then it was vertically dilated. Aha! So if it was then vertically dilated, it would be 4.5. Uh-oh. Whoa. I don't know what's going on my screen. Hold on. All right, this one looks like it's already been moved down and over, and then vertically. If they vertically dilated it, then this would move up, right? So they want us to write the equation. We're going to have to make that 9 is going to have to be 4.5. So then it will get, because this has not yet been dilated right here. This is just a parabola, so it's going to have a vertex right here at 4.5, but it's going to have the same exact zeros that it had before. So let's try putting this in here. Okay, so we're going to go like this. We're going to start by giving a factor of 1/2, and then we're going to multiply that by x. Let's see, we wanted to go to the right 4, so x plus 4 squared, right? And then I'm going to go minus 4.5 and hit enter. And so now 1/2 times this minus 4.5. So why do I have different zeros? Let me just think about this. 1/2 times this. You know what I can do is I can do it like this. Yeah, I might have my numbers. I have to go back and take a look at that again. Well, we wanted to go down. I know we wanted to go down 9, right? Put this in 9, and then I will open that parentheses and like that. I just don't really want to get rid of that parentheses there. I'll hit enter. Yeah, there it is. So f of x equals 1/2 x plus 4 squared minus 4.5. I'm not sure what the circular definition is. Didn't like function f. I'm not sure what it's upset about there, but we do have the axis of symmetry at -4, 4.5. So that's how that would look. Okay, describe how the graph of each function compares to the graph of g of x equals x squared. So the difference with this one is that it has been shifted. See that -3 tells me it's been shifted to the right 3. And this one would have been shifted to the let's see, to the left 7, or translated to the left 7 and down 8, and then the whole thing would be reflected across the x-axis, right, with that negative sign there. So to the left 7 and down 8, and then the whole thing gets reflected across the x-axis. Okay, that is it. That's all we're going to have for you guys. Get ready for the test on Tuesday. I hope if you need to go home and keep watching this video, do it.